Hi, ladies and gentlemen. I welcome you to our YouTube channel. My name is Professor Kevin. So please, before you can watch this video, if you haven't subscribed, just subscribe now and like our video. And don't forget to share with your friends or your fellow learners. So on this video, we'll be talking about the implicit differentiation. We'll be talking about the implicit differentiation. So if you haven't watched the first video that I just uploaded of the derivatives of polynomials, please do yourself a favor and watch that video, because everything that we'll be doing here is just the continuity of what we did. So do yourself that favor so that you can move with us on this video. So on the implicit differentiation, we are still going to differentiate each and every term. We are going to differentiate each and every term. So for example, let's say we have x squared plus y squared is equals to 7. So at the end, you must find dy over the x. At the end, you must have dy over the x. So what we're going to do here is to differentiate each and every term or that we have on our equation here. So I will start, say, differentiate. We're going to differentiate x squared. Again, we are going to differentiate y squared, and then we also have to differentiate 7. The first step is to differentiate every term that we have. Then let's find out what is the derivative of x squared. We are going to get 2x. And then how about the derivative of y squared? So one thing you need to know is that the derivative of y squared, it is still the same as the derivative of, we can write it in this fashion, f of x all squared. This still means the same thing because y is still the same as f of x. So okay, here we are going to apply the chain rule. Okay, the chain rule says that we start differentiating outside, so it means I'll drop these 2, so we're having 2, and then we keep what we have inside the way it is, multiply by f of x, and then we are going to subtract 1 from our exponent. Then if we subtract 1 from 2, we're still going to get to 2, so it's still the same thing, multiply by the derivative of what we have inside. What we have inside is f of x, so the derivative of f of x is still the same as f prime x. It is written in this fashion, f prime x. So this is the derivative of f. So you can write this as because we know that f of x, it is the same as y. So we can come and say, okay, the derivative of y squared, it is 2y multiplied by f prime y. So you can write y prime, or you can write f prime x. It is still the same as dy over the x. So multiply by dy over dx. That is how we differentiate y. Again, let's continue, and then we are going to differentiate 7. If we differentiate 7, we are going to get 0 because that is a constant. So let's make dy over the x to be the subject of the formula, because that's what we need to find at the end. So I will move everything that is close to dy over the x. So I'll start by this 2x. So we're going to have 2y multiplied by dy over the x. It is equals to negative 2x. And then I'm going to divide both sides with 2y. And then dy over the x, I'm going to get negative x over y, because 2 and 2 will divide each other. So at the end, this is our final answer. So this is how we apply the implicit differentiation. Again, we can still have this example. We can still have this question. 2x to the exponent of 4 plus y cubed is equal to 4x. So let's apply the implicit differentiation. The first thing is to differentiate every term that we are having there. So I'll start with 2x to the exponent of 4 plus the derivative of y cubed is equals to the derivative of 4x. So this is how we apply the implicit differentiation. So the derivative of 2x to the exponent 4 is going to give us 8x cubed plus the derivative of y cubed. As I said, we can still write y cubed as f of x, because y, it is still the same as f of x, all to the exponent 3. Okay, so we are going to apply the chain rule even here. So we're going to keep these 3, and then we keep what we have inside, which is f of x, and then when we subtract 1 from our exponent, we're going to get 2. Okay, it means we have 3 multiplied by f of x all squared. And then again we multiply with the derivative of what we have inside. So what we have inside is f of x, so it is f prime x when we differentiate it. So we can come and write it here as, because we know that f of x is still the same as y, so it means we have 3y squared multiplied by f prime x. It is the same as dy over the x, that is the derivative, is equals to the derivative of 4x is going to give us 4. Then now we need to make sure that dy over the x becomes the subject of our formula. So let's move everything close to dy over the x. I'll move this 8x cubed. So we're going to have 3y squared multiplied by dy over the x is equals to 4 minus 8x cubed. So now we are going to divide both sides with 3y squared, and then dy over the x is going to give us 4 minus 8x cubed all over 3y squared. So that is the final answer. So this is our derivative. So this is how we apply the implicit differentiation. Let's go ahead and do this one. So now our question is to differentiate x squared y plus xy squared is equal to 10. So again, we are going to apply the implicit differentiation. We start by differentiating each term that we have in here. So I'll start with the derivative of x squared y plus the derivative of xy squared is equals to the derivative of 10. So if we can check the first term that we have here, it is x squared y. There, if we can check, we are going to apply the product rule. Okay, we are going to apply the product rule. The product rule says that you can keep the first term the way it is, x squared multiply by, then you can differentiate the second term or the second function plus. Okay, now we are going to keep our second function and multiply by the derivative of the first function, which was x squared. Okay, plus even here xy squared, we are still going to apply the product rule. So we are going to keep our first function and then multiply by the derivative of the second function, which is y squared, plus we are going to keep our second function and multiply by the derivative of the first function, which is x, is equals to the derivative of 10. This is a constant, it's going to give us 0. So let's simplify this, x squared multiplied by the derivative of y. It is going to give us y prime, or dy over the x, dy over the x, because y, it is still the same as f of x. So if we differentiate f of x, when you apply the differentiation, this is going to give us f prime x. So f prime x is the same as the y over the x. It's still the same thing. So nothing much. Then plus a y multiplied by the derivative of x squared is going to give us 2x multiplying by 2x, and then plus x multiplied by the derivative of y squared is going to give us 2y multiplied by dy over the x plus y squared multiplied by the derivative of x. It's still the same as 1 is equals to 0. So even here, we must make sure that at the end we have dy over dx. Let's make it to be the subject of the formula. So we must move everything that does not have dy over dx, just like this term and this term must be moved to the right hand side. So let's just factorize with dy over dx. Dy over dx is going to give us x squared plus 2xy, because when you multiply x and 2y there, you are going to get 2xy. I just factorized with dy over x is equals to, so let's take this one to the right hand side, is going to be minus 2xy. Even this one is going to be minus y squared. So now we are going to divide with everything close to our dy over the x. So I'll come and write our final answer here. Dy over the x, it is going to give us, and then we can keep this negative outside, and then we'll be having minus, can write it as 2xy plus y squared all over, then we divide with what we have there, which is x squared plus 2xy. So this is our final answer. So this is how we apply the implicit differentiation. Let's do the last example. So here it's our last example. So here we have the square root of x plus y plus 3 square root of xy is equal to 6. So even here we are going to apply the same thing, is to differentiate each and every term that we have there. So we are going to differentiate square root of x plus y, and then we're still going to differentiate. Okay, you can keep the constant outside, and then differentiate square root of xy is equals to the derivative of 6. Yeah, you can keep that constant of 3 outside just to make things easier. It's not a problem even if we put it inside, not a problem. Then now let's write this thing in the exponential form, or let's just write it here to make things easier. We know that square root is the same as exponent 1 over 2. So we have exponent 1 over 2 here, and then even here we're going to have exponent 1 over 2. So now for this one, the derivative of x plus y all to the exponent to half, we are going to apply the chain rule. So the first thing there is to drop our exponent of 1 over 2, and then we keep what we have inside the way it is. Then we're going to subtract 1 from our exponent, and then we're going to get negative 1 over 2 multiplied by the derivative of what we have inside, which is x plus y. Then plus 3. Then let's keep this 3 outside. Let's focus on the, sorry, I supposed to remove this square root because now we write it in the exponential form. And now we're going to differentiate xy all to the exponent half. So even here we are going to apply the chain rule. So we're going to drop our exponent, which is half, and then we write what we have inside, which is 1 over 2. Then which is xy, I mean then we subtract 1 from 1 over 2. We're going to get negative 1 over 2 multiplied by the derivative of what is inside, which is xy. All these things is equal to the derivative of 6, which is 0. Then now let's make things easier. So here let me write this in a positive exponent. It can be 1 over 2 square root of x plus y. You need to do the laws of exponent very well. Plus, or multiply by the derivative of x plus y. So the derivative of x, it is 1. It is 1, and then the derivative of y, it is dy over dx. Plus, we have 3 outside there. So you can still multiply this 3 with with 1 over 2, but let's do that later. Then even here, let me write these things in the positive exponent. So it will be 1 over 2 square root of xy multiplying the derivative of xy. So here we're going to apply the product rule. So let me come and write it here just to save space. So this one, we are going to keep the first term, which is x, and multiply with the derivative of the second term. So the derivative of y, it is dy over the x, plus we keep the second term or the second function, then we multiply with the derivative of the first function, which is x. So the derivative of x, it is 1. So it means here we're going to have x multiplied by dy over the x plus y multiplied by 1 is the same as y is equal to 0. So at the end, we must make sure that we are left with dy over the x only. That's what we need to find. So let's simplify this thing, and then here 1 over 2 root of x plus y is going to multiply 1, and then if it multiplies 1, it still remains the way it is. 1 over 2 root of x plus y again, plus is going to multiply dy over the x, so it will be 1 over 2 root of x plus y multiplied by dy over the x. Then plus here we're going to say 3, we're also going to multiply with 3, so 3 multiplied by 1 over 2 root of xy, it will be 3 over 2 square root of xy. Then we still have this here, we're going to multiply, so we are going to have 3, then it will multiply 1 and this x, so it will be 3x over 2 root of xy. We still have dy over the x, dy over the x. Then again, this 3, when it multiplies 1 over 2 root of xy, it will be 3 over 2 root xy. Then it will also multiply that y, so it will be 3y over 2 root of xy is equal to 0. So let's make dy over the x to be the subject of the formula. So here, let's leave the one with dy over the x on the left hand side. I think we have this one and this one. So it means we'll take the one that does not have dy over the x on the right hand side. So let's also factor out with dy over the x. dy over the x, we will be having 1 over 2 root of x plus y. Then we also have plus 3x over 2 root of xy is equals to, so let's move the one without dy over the x. The first one is this, it will be minus 1 over 2 root of x plus y. Again, we have this one, which is minus 3y over 2 root of xy. So this is what we have so far. So what we need to do now to make things easier, let's find the LCD. We need to write these things on the same fraction so that things can be simple. So if you can check on the left hand side and on the right hand side, it seems like we're going to have the same lowest common denominator or the same LCD. So the LCD for both fractions is going to be 2 root of x plus y multiplied by root of xy. This will be our LCD. That one will be our LCD. So let's solve this one first. So dy over the x, we are going to have, I said the LCD is 2 root of x plus y multiplied by the root of xy. So here we are going to have root of xy plus, on the other side we'll be having 3x root of x plus y. So let's see good what are we going to have on the right hand side. So we can still factor out with negative if we want. So if we factor out with negative, everything there is going to be positive. So, but when we factorize with negative, doesn't change our LCD. Our LCD will still be 2 root of x plus y multiplied by root of xy. So this side we are going to have root of xy. So instead of minus, because of factorized with negative, we're going to have plus 3y multiplied by root of x plus y. This is what we'll be having. So if you can check now, the denominators on the left hand side and on the right hand side are the same. So just like if you have x over 2 is equals to 3 over 2. So when the denominators are the same, you can simply cancel the denominators and equate the numerators. So it means x will be 3 on this case. So same applies as here. We can be able to cancel those denominators since they are the same. So to make things easier, it means dy over the x. In this, we are going to have a root of xy plus 3x root of x plus y is equals to negative into root of x y plus 3y root of x plus y, because we have simplified those denominators, we cancelled them. So now we can be able to divide both sides with everything that is close to dy over the x. So our final answer, dy over the x, it is going to be negative. You can keep it outside, and then we have a root of xy plus 3y root of x plus y, all these things divided by root of xy plus 3x square root of x plus y. So this will be our final answer. This will be the final answer. I hope you have enjoyed this video. So please don't forget to like our video and also subscribe to our channel. So if you have any maths problem, you can send your problems on this number 06627648110. You can call me or WhatsApp me on this number. So thank you guys for watching this video. Please do not forget to subscribe and share our video. Sure.